bar graph or maybe like histogram.
Okay. So it's one student and it's probably not that much data. So it
Oh, but
could
it's
be,
not categories, so it couldn't be a bar
yeah,
graph.
it's not categories, it's
Is
just
it box
numbers.
and whisker?
That that would be a good option. That would be okay. All right, how about and you just have to explain your reasoning. I think
Yeah,
that's a good one.
because there can be
Uh,
multiple graphs.
Yes.
This is a percentage rise each month. Would that be a histogram or a bar graph?
Remember bar graphs are for categories.
Okay, so it'd be histogram.
Histogram are for like counts. But it's a little bit weird because we need more context. Like, is it every month that you're getting this information? Um,
I mean, it
so
says each month.
yeah, so it's like over the course of 12 months. So that's not really a histogram when there's time involved,
Oh,
as is
it's a
the
line
case.
graph.
It probably better off as a line graph. Yeah. Okay. Now the next one, 6, the outcome of rolling a number cube.
Um,
That's where you're doing it a lot and you want to see what the results are. There's a lot of counts.
oh, it'd be that one where you like do ticks. Like so you
Well,
have
you
like
we
a one.
it ends up being a histogram because you care about how many like zeros, one. Yeah, you do the picks, but they turn into
I
I
was
guess you don't.
gonna choose like the I was gonna do the pictogram. You do
Pictogram
one and then
rarely used in this.
or no, a line plot. I was gonna do a line plot. Sorry, not a pictogram, a line plot.
Line plot's only good for time data. So the histogram would be like, okay, I got that many, threes,
Oh, but it doesn't
fours.
ask how many times each value occurs in
Yeah.
the yeah.
Yes.
Okay.
All right. So homework
Problems.
problems
Okay.
assigned each day.
Those are categories, right?
It's just a count. It's like
Oh,
okay, so
like
here
just another word
this
for
might help you. It's like, okay, on Monday you got 10, on Tuesday you got 15, on Wednesday you got
yeah,
12. Now, yes,
histogram.
so no, well, they are categories though, because the bar graph, the category is the day.
So, oh, okay. So if it, but uh, would it be a histogram
No,
for number,
no, it's a
would bar graph not work for number six? Because
it
like,
has
but what if numbers,
six has to be a histogram.
is it because there's like not, because there's only one? Why
Yeah,
would
it
six be a histogram?
because the results are they're not categories. Like it's a numerical value
Oh,
of the result.
okay. Okay.
Got it?
Yeah.
Okay. So that takes care of that. Let me go back to your picture here of what you sent over. Okay, so two-way tables. Two-way tables. Okay, let's look at this table. All right, so this table shows gender on the top here, males and females, and party types that they want: bowling, skating, dancing. And I'll just remind you here that I can ask you questions about columns, rows, single cells, and then overlaps. So
So
let's
like how
start.
many females prefer skating out of the total?
Yes, that would be, but the overlaps are typically or. Single cells are the word and. Rows and columns are just the category.
Okay.
So I could ask you the probability of bowling. How many?
Bowling out of the total or out of,
Well, so yeah, so it's the total number of bowlers out of the
yeah, so
total.
it would be 8 divided by 26.
Okay, and then you have to reduce that or go to a calculator.
Yeah, I was just
So,
gonna divide it.
okay.
Calculate
So probability of female.
it. For bowling or to
No,
have a
just
party?
female, just
Oh,
female.
16 divided by 26.
Yeah. So notice if I don't give you information, it's the total.
Yeah, it's the totals. Okay.
All right. So that's 8 out of 13. Now here's something else. Probability of not dancing. Not dancing.
Dances needed, so it'd be 22 out of 26.
That's right. All right. So that's kind of the single rows and columns. Okay. Row and column information. So now the next thing is I could ask you about and I could say, okay, the probability of male and skating. That's a single cell.
A male dancing.
Yes.
What's the S?
I'm sorry, male and skating. Sorry. S
Dancing and
stands for,
skating? Okay.
no, male and skating.
Oh, that's an and. Okay.
Yeah.
And skating. So then skating would be 3 out of 10.
It's 3 out of 26. So whenever it's a single cell, it's that over the
Oh, it's
total.
out of the total.
Yeah. So
As opposed to
probability
the
of like
total.
female bowler would be what out of what?
Female bowler.
Yes, female bowler.
Would that be 2 out of 16?
It's 2 out of the total.
But the
So
total
and
is male and female.
no, if it's male and skating or female and bowling, it's the single cell out of the total. It's different language when you're restricted to a row or to a column or a row. We can get into that,
Okay.
which I think is what you're asking. So let's do that. Um, so it would look like this. What's the probability that the person is female given this word, this line here means given that they dance? Okay, so the given tells you that you're restricted to either a row or a column. So in this case, your whole world is just dance.
Okay, so
Probability of
it'd be just the dancing. So it'd be 1 out of 4.
there's one male out of 4. We want female.
Oh, 3 out of the 4.
Yes. Okay. Now we can similarly go the other direction. We could say, what's the probability of skating given that it's male? So this time you're restricted to a
3 out of.
column. 3 out of 10. Yeah.
Oh,
like
it'd have
that.
to be skating. So it'd have to be skating and then male, not male and then skating. If it was male and then skating, it'd be out of 26.
Well, it's the language. So there's this word like given that the person is a male, what's the probability that they like to skate? It's all in the language. And I'm gonna look for some better questions because these I'm just sort of making up that along the way. So let me go grab some questions here. All right. Okay, I think this is more in line with what you guys are trying to do. So let me snip this in. All right, so first thing I want you to do is to help me fill out the table.
Let me copy it down.
Sometimes they don't give you the totals and you have to calculate them.
Cash 20, 168, 72, 60, 11, 3, 7, 8, 9. Can swim, can't swim. Total. Total. So then the total for can swim would be, let me get calculator. 120 plus 168 plus 172 is 460 for
Okay,
can swim from
okay,
all
I
grade.
agree. How about cannot swim?
74.
Okay, good. And then you can calculate the horizontal totals as well. We will likely need them.
Okay, so then 180 for grade 7.
Okay,
179 for grade 8 and 175 for grade 9. The total should be, if if the table is right, 534.
it's always good to check it both directions, like add all these up vertically, add these up horizontally, make sure they are the same, because if they're not, every answer will be wrong.
Yep.
So is it good?
15. So that's 8 plus 8, 16. 3. Yeah, it works.
Okay. All right, so there's a bunch of questions that we can answer now. Let me see if I can move this. So I'd like to do these together one by one in case there's mistakes. Or if there's any issues, I don't want it to go all the way in. So how many students need swimming lessons? What does that implied in this? Or what is implied by that if they need swimming lessons?
They can't swim.
They cannot swim, yeah.
So it'd be 74 out of
They're just
500.
asking, they're asking how many students, they're just 74.
Oh. So B is 74.
I'm sorry, C is 74. Sorry. Yes. How many students are there in 8th grade?
179.
79. How many of the 7th grade students cannot swim?
60.
60. Okay, so we're kind of,
Oh,
these
it'd
are
be
just like,
60 divided by 74.
well, it says how many, it's not actually for what percentage. So let's go down here and answer question I, J, and K. What percentage of 9th grade students can swim?
9th grade students, so it'd be just the row.
That's right.
So it'd be 172 divided by 460.
Yes.
172 divided by 460.
No, I'm sorry. No. What percentage of 9th grade students can swim? So your whole world is the 9th grade row.
Oh, it's not the column?
Well, when it said whatever it says here, whatever category it says, 9th grade students, that's your row,
Oh, no,
that's
it's
your column.
172 out of 175.
That's right.
So it'd be 98%.
Yeah, it's pretty high, pretty darn high. Okay. What percentage of students cannot swim? So the students is the whole table.
Would that be a row or a column?
It's the whole table. These are all the students. Students could be in grade 7, grade 8, grade 9,
What percent of students can swim?
cannot swim,
Oh, can swim.
cannot swim.
Could be 74 out of 534.
Yes, yes. Okay. The last one here is what percentage of students are ninth graders?
So then it'd be 175 divided by 534.
Yes. Good. Okay, so
So
here, question on that?
no,
All right. This is a good one. It's you have to try filling in the table.
okay. Oh, so then you'd have to add up the totals and then. Okay, so I see what we have to do. So 40, yeah, and then the total is 484.
Yes. That's, I mean, that's down here in the lower right.
Yep. So then it'd be that's 36 plus 55. 36 plus 55 plus 144 is 2. So then the girls' total is 235.
Okay, 235 for the girls. How did you come up with that?
I
Oh,
just
there it
added
is.
them.
I'm sorry. There it is. Yeah, I'm sorry. I was looking at something else. Yes, good.
And
Keep
then
going.
161. Oh, wait, so then 484. 484 minus 235 minus 40 minus 161. So then sometimes wears glasses for boys is 48.
This one right here.
Yep.
Okay, so you got 76, 305,
And
and
then
then what did you have here? 103. That looks
yeah,
right.
103.
And then 249.
Yeah.
Okay. So the table, you got to fill the table out, right? There's no way to proceed without that. So let me throw some percentage questions again here. All right, so here's 3 questions.
Percentage of girls never wear glasses. So girls, so it's 144 over 305. Right?
Okay, so the 144 is right, but it's just girls. It's
Yeah.
just girls.
Oh,
So
wait, I keep doing rows. So it,
could be a
because,
row, could be a column.
so it's a
Uh,
row. I keep doing column.
yes, yes, this one is a row.
It's 47%.
Okay,
Percentage of students are boys. So this is 249 out of 484.
boys is 249 out of 484.
51%.
Right. What about the last one here? Percentage of students always wear glasses.
Always wear glasses. So that's 76 out of 484.
You got it.
So then 16%.
Okay. I think you're getting it. Doing real well on that. Here is, I guess, one for you to try start to finish, although it's pretty much the same as what we just did. Let's do one more of these and then we'll switch to another topic here.
Okay, so then the total. Okay, so 33 minus 19. You have to start with that one. So it's 14. So the physics female is 14. So
Okay,
then 14 plus 18 is 32. So then the chemistry is 15,
good.
which means the male chemistry is 6.
Okay,
So then 80 minus 33 minus 21 is 26. Then the total for biology is 26, which means 18. So then, which means that's 8. And then that's 33 for the total.
okay. So just give me the fractions for these. I know you can enter them into the calculator. I'm just curious about the
Student studies physics. So 33 over 80.
33 over 80 agreed.
My student is male and does not study biology. So male, but no biology. So 25 out of 33.
Yes. Sometimes it's good to even just say them. It's like, I'm sorry, not at 30. It's chemistry and physics. Um, when it says male and, the ands are the single cells, but then it's out of the total. You're not saying that it has to be, you're not saying out of all the males, what is the probability that it does not study biology? It's a little nuanced, but it unless it says that you're limited to a row, and maybe that's what the issue is. So let's go back and look at this previous one. What percentage of girls never see how it's isolating it to girls? Like it's just girls.
Yeah.
This problem here isn't asking about just males. It's saying it's not saying what's probably that males do not study biology. It's male and does not study biology. Because it's starting out with all the students.
Okay.
Maybe it's still not clear, but the next one
So it's
is
female
female
and
and
studies chemistry,
it's out of the total number of students.
but the
Total
total number
numbers.
of students is male and female.
Right. So it's but okay, yeah. They're saying out of all the students, probably that female and studies chemistry.
Oh, so it'd be 26 plus 15. So it'd be
Well,
41 out of 80.
female and studies chemistry is just 15.
Oh,
Okay. I know this is not going. The issue, I guess, is just being comfortable with this idea that unless it tells you to restrict you, it'll say something to restrict it to a male, like a row or a column,
so
but
if it
these
doesn't
are
say
not.
anything like that, it's always out of the total.
Yeah, and the and is kind of a keyword that's out of the total.
Okay.
Okay, we should try a different topic here. All right, shapes of distributions. All right, so here's some questions. All right, so on the left here, we have adult male heights. On the right, adult female heights, mean is 70, standard deviation is 3, mean is 64, standard deviation is 2.5. Okay, so from here, I wonder if this is true. Maybe it's just whatever. Because they're not overlapped, you kind of have to like decide, well, where would the peaks be if they were on the same graph? And the mean is what tells you that. The mean tells you that the females are below the males. Okay. But that's not what it's asking. It actually is just asking for which has a smaller standard deviation.
Um,
How would you answer that?
adult female heights. Or
Yes.
smallest standard
Okay.
deviation, adult female.
Yes. Yes. So they're saying
And that just means that they female heights um are closer to the mean, like they don't female heights are
they're squeezed
closer
together. They're
together than male
yes.
heights are, like they don't
Yeah.
there's not as many outliers, maybe.
Be careful with that word, but it's see how the distribution is a little bit wider on the left and the one on the right is a little narrower. You want to use words like wider, narrower. All right, and you don't actually know enough to be able to answer this question, meaning like you haven't seen it in class yet.
Okay.
All right. So you have to know these three shapes of your distributions. Skewed left means the tail is to the left. Skewed right, tail is to the right. Okay, and symmetric, well, it's symmetric. It looks symmetric. All right. So the first type of problem you will see is where they give you some sort of data set, something like this, and I want you to construct a histogram of this, please. It doesn't have to be very, very solid, but a histogram, and then you want to draw like the curve over it.
Okay. So then I just draw up the categories pretty much.
Yeah,
So
the
then
rectangles for the heights.
26 to 50, 51 to 75, 76 to 100, 101 to 125, 126 to 150, 151 to 173, 176 to 200. And then I'll probably go up to like 10. So it's 2, 4, 6. I'll just go up to 8. So then 26 through 50 is there. I didn't draw mine close enough together where they could be touching, but I know they have to be touching.
Yeah, they do have to touch. That's a big part of it. Like that's a deduction. And then the bar graph does not touch, so you have to be able to distinguish between them.
Yeah. Okay, I finished. And then it
Okay,
kind
so
of like,
try to put a thing over it, and I'm going to snip in the answer.
and the data is streaks. It's like
Is it
not
skewed
streaks,
left, symmetric, or skewed
skewed
right?
right, skewed right.
It is skewed right. Good. Here's what it looks like or should look like. All right, so here's another one for you to try. Again, make sure those rectangles really they touch, they're tight.
Um, and finished.
Okay. What kind of, is it less skewed left, symmetric, or skewed right?
I got skewed right. Or sure, yeah, skewed right. Yeah.
It is, yeah, it is skewed right. Okay, good. All right. Okay, so the other type of problem you might see is where they give you stem and leaf plot, and you also have to create a distribution. The problem is these are kind of on their side. So you have to you need to rotate, you almost need to rotate your paper or page left. This one on the left is skewed right. And this one on the right is symmetric.
Okay.
Is that okay? Clear?
Yeah.
All right. Here's a good one. We do need to talk a little bit about box and whisker plots. We've talked a lot about how to make them, but let's just say most of the information is given for you. And they want you to make 2 box and whisker plots for this. Like one for females, one for males. Basically put them on top of each other and see what you come up with. You know, is there like a discernible difference between them?
Just by eyeballing it or by making the box?
You have to make the 2, you know, like one each, you know, and you'll see this is not right, but you'll see, oh, okay, that one, and it's like that, and then
Okay.
yeah, this one's
So the median, this one is 38. And so 38's in the middle of the data set. The max is 52. No, I gotta do the third quartile first. That's 6 over 26. 8 over. First quartile is. This one's looking pretty symmetric. The first males is looking pretty symmetrical. Let me see what the first.
okay.
See what the first quartile.
I would tend to agree about the
It's a little like it's max and min are a little like there might like 18 is probably an outlier.
uh just stick to making the let's not worry about outliers quite yet.
Okay. So
Just,
then median is 20.
and I agree. I think they're symmetric the way you've.
And then third quartile is 32. And first quartile is 24. Minimum is 16. Eat out. And the third quartile is. So yeah, they're pretty symmetrical. Both of them are.
And I agree. They're both symmetrical, but you probably see the females are slightly to the left of the males.
Yeah, their median is slightly left. Yeah.
Yes. Okay. All right. So here are some other questions that could be asked of you, and you can give me the answer sort of verbally. Or we can go back and look at the chart. It might require. So it says compare the number of hours listened by females to the number of hours listened to by males. So basically, they're asking like who on average listens to more music?
Males.
Males. So that's what they're looking for. When they say compare, you're trying to make a decision about who is listening to more or less or the same.
Okay. Well, I could have done that just by looking at the data.
That's true. That's true. But you may be asked to make a plot like this. We don't know. If we knew what was on there, we just work on those problems. Okay, about how many females surveyed would you expect to listen to music between 22 and 34 hours per week? So think about the min to Q1 is 25% of the data. Q1 to the median is 25%. They're all 25%. Median to Q3 is 25%. Q3 to Q4
What's
is also
Q4?
the max. Sorry, max. Sorry, I shouldn't have used that notation. It's the max. It is Q4, but they don't use it. They don't label it that way in this class. The max. So basically you got to figure out, well, where's 22? Is it the Q1? Is it the min? Where's 34? Is it the median? Is it Q3? Is it the max?
So we could look back at the data, right?
Yeah. Yeah. So
The
it's like
females,
24.
28. So
It's kind of first to third.
yeah, it's somewhere in there.
So that's the middle 50%.
Yeah,
And how many did they sample? Females?
50. So then it'd be 25.
Be 25. Good. All right. So now we can do the same thing. And maybe not. Okay, let me see what else is on your list here. All right. Quickly, we need to do a quick standard deviation calculation. So let's say I give you test scores of 80, 85, and 94. No, sorry, I'm struggling here. I want it to work out nice. Sorry, it's 5, 15, 93. Okay. Could you find the average of those for us, please?
The average of those? Okay.
Yes, yes.
Calculator. E plus 85 plus 93 divided by 3. 86.
Okay, so the average X bar is 86.
Oh,
So
are we finding the deviation?
to find the standard deviation,
So
first
then
thing we
it'd
do is
be
take each sample.
36 plus 2 plus what is 93?
All right, so yeah, so
Second.
80.
So that's 49. 36 plus 2 plus 49 is divided by 3 is, and it's square root of 29. But I got 5.39.
Or what?
Oh, wait, it's not 2. It's not 2. It's 1. This is
So
50.
you have to add all these up, which is 86.
Yep,
And
divided
so
by 3 is 28.66 repeating. So then
okay,
I got 5.35.
all right, 5.35. Good. Okay, so when do you use the median instead of the mean? And you mentioned this a few times already, and I said, don't worry about those for right now. It's when you have outliers. All right. So if your data is, and you can think of it as right skewed or left skewed, you will use the median. Is that okay? Clear?
Yep.
All right. What else is on your list here? Measures of centered variation, measures of centered variation, box and whisker plots. I mean, we kind of have done everything. Do you have any questions? Anything we haven't covered?
No,
All right, let's see what I can find here. All right, so here's a quick question. So could you decide who has the greater mean? I'm sorry, greater median?
greater median. Okay,
Median, yeah.
and then 15, 16, 17, 18, 19. 15, 16, 17, 18, 19. And 12, 13, 17, 20, 20. And then you have the same median.
Okay. How about the mode? Who has the greater mode?
The friend.
And what is that?
20.
20, good. All right. Yeah, I mean, I don't know. I wish I knew it was on exactly on there, but that's kind of it. I'll just throw one more thing up here. So they could give you a box and whisker plot and you could be asked to find some of this information. So the median's 131, the upper quartile is 135, lower quartile is 129, lower extreme 124, upper extreme is 160. The range is the max minus the min.
Inner quartile range is 135 minus 120.
Exactly. And yeah, these are just things you have to know to be successful.
Yep.
All right, we're gonna go ahead and stop there for today.